Okay, so I would like you, let's read the directions first. All right, it says for problems 1 through 6, determine the equation of the horizontal asymptote for the function and give a reason. If the function does not have a horizontal asymptote, explain why it does not. So I would like you to be able to answer questions 1 through 6, and then we will go over those. Okay, so number 1, determine the equation of the horizontal asymptote. Remember, what we need to do is identify the degrees and then compare them. All right, so it says since the degrees of the numerator and denominator are equal, then y is equal to 3 over 1, or y equals 3 is the horizontal asymptote. All right, let's compare number 2. We've got a degree of 1 on top and a degree of 2 on the bottom. So we should have y equals 0. So the explanation that would be adequate is, since the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. Notice on number 3, we need to rewrite this in proper standard form, and then we can compare them. And so now that it is rewritten, we should recognize that since they're the same, then the equation is the ratio of those leading coefficients. So since the degrees of the numerator and denominator are equal, then y equals negative 3 over 2. All right, let's take a look at number 4. They are equal. So since they're equal, then it's the ratio, which gives you y equals negative 1. And let's look at 5. The question was horizontal asymptote. So because this numerator is 2 and the denominator degree is 1, then there is no horizontal asymptote. Okay, so since the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So on 6, what we need to do is at least just try and figure out that leading coefficient. So negative 2x times x is negative 2x squared, dot, 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 because I don't care. And then x times negative x is going to give me over negative x squared, dot, dot, dot. I don't really care about the rest. Now I'm able to identify those degrees. Since they are the same, I end up with y equals 2 as my horizontal asymptote. Okay, let's take a look at 7 and 8. It says find the equation of the slant asymptote, and if it doesn't have a slant, explain why it does not. So take a moment and answer questions 7 and 8. Okay, so the first thing that we want to do is do synthetic division. So we first have to find out what to divide by. And so we're going to divide by negative 3, and then we are going to put 1, 5, and 8. And then again, we are going to bring down our first term, and then we perform synthetic division. We get to disregard our remainder, and then the final thing is to divide by the leading coefficient. So we're going to take that, we're going to divide by 1, and we get y is equal to x plus 2. Remember that the only way that you can have a slant asymptote is if the degree on top is exactly 1 more than the degree on the bottom. All right, so this is a degree of 2, this is a degree of 1, so let's figure out what our 0 is. So we're going to synthetically divide by 1, and so we've got 1, negative 1, 1, and then we bring down our first term, and then we end up disregarding our remainder, and then we have to, at the end, divide by the leading coefficient, and then that is going to give me y equals 1/2 x. All right, so 9 through 11 says using the graph, we are going to answer these questions. It says the graph has a removable point discontinuity at 3 and 5/3 and an x-intercept, which is this guy right here, at negative 1/3 and 0. Okay, so number 9, what can be said about the degree of the numerator compared to the degree of the denominator, and then give a reason. So answer number 9. Okay, so let's take a look. The fact that we have a horizontal asymptote at a position not equal to y equals 0. So the fact that it's not y equals 0, that tells us that the degrees must be the same. Okay. So since f of x has a horizontal asymptote that is not on the x-axis, then the degrees of the numerator and denominator are equal. Okay. Number 10, go ahead and answer that one. All right, in factored form, the way that we are going to be able to quickly identify the factored form, number one, would be to identify the asymptote. Well, the asymptote is at -3, so that's x plus 3. The whole is at x equals 3, so that's x minus 3 on top and bottom. And then we've got our x-intercept. So the only way that we can get to a -1 would be we would have to have subtracted 1 and then divided by 3. So that's the quickest way for you to identify the factor. You take care of the numerator here, and the denominator is going to be the coefficient right here. So in factored form, we get this, and then all you have to do is simply multiply that out. Okay. Number 11, give 2 reasons why the standard form of an equation that we wrote in number 10, so this is standard, makes sense in the context of the graph. So what could we do to just kind of make sure that we did that right? Okay, let's take a look at one of the reasons. Well, the ratio of the leading coefficients, 3/1, would tell us the value of that horizontal asymptote, which is y equals 3. And according to the graph, that is correct. Number 2, the ratio of the constants, which is the end, -3 over -9, is the y value of the y-intercept of the graph, which is going to be 1/3. Okay, which is right there. Okay, the y-intercept right here. All right, number 12. Here's the graph of the function, and it's pictured, right? Find the equations of the asymptotes of the graph and then draw them on the graph. All right, so we definitely can tell that there's going to be a vertical asymptote. So let's find that one first. So we set that denominator equal to 0 and solve. So we end up getting x equals 3. So we are going to draw that vertical asymptote on the graph, and we're going to label it x equals 3. Now, the next thing we can tell is that there's definitely a slant asymptote, which means we need to perform synthetic division. So we now know that the 3 is going to be what we need to divide by. And so I've got 1, -7, and 2. Again, we bring down our first term, finish off that synthetic division, disregard our remainder. And then remember, though, we always have to divide by that denominator leading coefficient. So I'm dividing each of those by -2, and I end up getting y equals -1/2 x plus 2 as the equation of my slant. Let's take a look at 13. So I would like you to, we need to go back and draw this. So we've got plus 2, and then we are just going to go down 1 over 2, down 1 over 2. I'm just drawing as many dots as I can, and then I connect those dots. Okay, so that would be my slant asymptote. So now let's do number 13. So go ahead and answer the questions that follow for 13. All right, so for 13, the easiest one to find, again, would be the vertical asymptote. Okay, and so we end up getting x is equal to 1, so we're going to draw that on the graph. Notice that we aren't having a horizontal asymptote, so we have a slant, so that means we're going to do synthetic division. We're going to synthetically divide by 1, so our coefficients are 1, -1, and 3. Bring down that first number, finish synthetically dividing, disregard the remainder, and then remember we are going to divide by the denominator's leading coefficient, which means we are dividing by 1. That ultimate gives me y equals x as the equation of the slant asymptote, which means we have an equation that looks like this. Okay, and then you can connect them. All right, so try 14. Okay, let's see how well you did. Let's see if you were able to find out that the vertical asymptote was x equals -2. And then we're going to synthetically divide. And then we get to disregard that remainder. And then remember, though, we have to divide our result by the leading coefficient of the denominator. So our equation is y equals 1/3 x plus 1/3. So I'm going to go and start right here at about 1/3 right here, and then go up 1 and then over 3. Okay, and then up 1, then over 3, down 1, over 3, down 1 over 3, and just sketch that. Okay, so and that's it. Make sure you address any questions that you have.